Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we will be implementing algorithms and data structures using Scala functional programming approach. All the code related to our development can be found in the description as a link to my GitHub repository. This video is about insertion sort. I have divided insertion sort into two parts. In part 1, we will understand what is insertion sort. We will walk through an example, and in part 2 we will be implementing the insertion sort itself. So let's begin. What is insertion sort? Insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. It is much less efficient on large lists than more advanced algorithms like quicksort, heapsort, or merge sort. Insertion sort iterates, consuming one input element at each repetition and grows a sorted output list. At each iteration, insertion sort removes one element from the input data, finds the location it belongs within the sorted list, and inserts it there. It repeats until no element remains or no swapping can be done. Sorting is typically done in place by iterating up the array, growing the sorted list behind it. At each array position, it checks the value there against the largest value in the sorted, which happens to be the next to it, and in the previous array position checked. If larger, it leaves the element in place and moves to the next. If smaller, it finds the correct position within the sorted list, shifts all the larger value up to make a space, and inserts that into the correct position. So let's see with an example. Now here this is a list which has an element 8, 6, 9, 3, 5. So here it picks 8 is the first element, so it will take the first two elements 6 and 8. It will compare, so it will compare with the left element, and 6 is less than 8, so it will swap, and 6 will be in the first position. It's the inserted here, and 8 will move to the next. Now it will go to the next item, which is 8 and 9. So 9 is greater than 8, so no swapping is done. List is already in order, so it will be moving to the next pass. So in third pass, now it encounters 3, so which it will compare with 9. So the value of 9 is greater than 3, so it will swap. Now again 3 will be compared with 8, so value of 8 is greater than 3, again a swap, and then again 3 will be compared with 6, and again there will be a swap. So similarly, likewise, same thing will happen with 5, and eventually it will end up here, and the list will be sorted. Couple of things to note about the insertion sort is it is stable and does not change the relative order of the element with equal keys. It is in place, only requires a constant amount O1 of additional memory space, and it is online and can sort a list as it receives. So let's take a look in the time complexity. When it comes to time complexity, the time complexity is O(n) square. So it is better than selection sort or bubble sort in practice, and it works pretty well with the small set of array, and space complexity is O1. So we will implement this algorithm in the next part 2. So if you enjoyed this video, kindly like and subscribe, and do not forget to press on bell icon to catch on future updates. See you in the next video. Thank you.